Advanced Algebra 2 Semester Exam Review, Unit 8, Radical Functions and Rational Exponents. So first we're going to start off by finding the inverse of the function. So to find an inverse, it ultimately involves switching the values of x and y and then simply just rewriting it in terms of y. That way you're using inverse operations to create the inverse function. So we have to remember that f of x is just fancy for y, and so we're going to rewrite, and everywhere we see a y, put an x, everywhere we see an x, put a y. So we have x equals 9y minus 3. And then we just want to isolate y again, and this will let us use those inverse operations, which creates the inverse function. So undo the minus 3 by adding 3, x plus 3 equals 9y, and then divide by 9 on both sides. So the inverse function ends up being x plus 3 over 9, and we show the inverse by using a little power of -1. So if you see that little f to the -1 power, that simply means that we're talking about the inverse of f, not f itself. Number 8, solve the following equation for x. And so we already have the base that the exponent is affecting isolated. We simply need to undo the 3/2 power. So if we remember our exponent rules, power of a power, that means these would multiply. And I can be strategic and I can raise both sides to a power so that this occurs over here, and I can get rid of this by making it into a 1. So 3 over 2 times the reciprocal, that's going to result in a 1. So we want to raise both sides of the equation to the reciprocal of the power. So we're going to raise this side to the 2/3 power and then raise 64 to the 2/3 power. And we end up with x equals, and if we remember, the 2/3 power simply means the cube root of 64 squared. That's all that means. And so now if we know that the cube root of 64 is 4, it's a perfect cube, this becomes a much simpler problem. If you don't remember that the cube root of 64 is 4, you can come to the side and we can break down 64, and we can try to find groups of 3 numbers all multiplied together. And so we see that there are 3 2's and 3 2's with no numbers left over out of a group. And so this is going to simplify into 2 times 2, which is 4. So our equation becomes 4 squared, and that 4 squared is 16. Solve for x. Now we have a cube root problem, and so we need to make sure that the cube root is isolated, which it is, and now we can undo the cube root. We undo a cube root by cubing both sides of the equation. So the cube of a cube root are inverses, so those will cancel, simply leaving us with 3x minus 2, and 4 to the third is 64. 4 times 4 times 4. Now we're going to simply solve for x, and we end up with 66, divide both sides by 3, and x is equal to 22. Now, because this is a cube root, there are no possibilities for extraneous. The cube root function looks like this, and that would be a domain of all real numbers. Since there are no restrictions, then there is no possibility for extraneous. So 22 is a valid solution. Number 10, solve for x. This time we have a square root function. And so again, we need to make sure that the square root is isolated, which in this case it is. We undo square roots by squaring, and we have to do that to both sides of your equation. So 6 squared makes 36. Squares and square roots are inverses, resulting in 2x plus 12. And then again, we simply must make sure that we just go solve for x. 24 equals 2x, divide by 2 on both sides, x is equal to 12. Now, the square root function starts at 0 and goes out to the right, and so my domain of the square root function is 0 all the way to infinity, 0 included, but we chop off all the negatives. So because this domain is restricted, there is a possibility for extraneous solutions. So we must plug 12 in and make sure that this creates a true statement. So let's check our work. So 6 equals the square root of 2 times x, which is 12, plus 12. So 6 is equal to 2 times 12 is 24. 24 plus 12 is equal to 36, and the square root of 36 is 6. So 6 is equal to 6, which is a true statement. So 12 is a valid solution. Another square root equation. Again, we must make sure that the square root is isolated, which we have that. To undo a square root, we square both sides. And now we have a binomial squared. And so this is going to require double distribution. We cannot just square each term and say that that is squared. So this is going to require double distribution. So x times x will leave us with x squared, x times negative 3, negative 3x, negative 3 times x, negative 3x, negative 3 times 3 is positive 9. Then we will collect like terms. X squared minus 6x plus 9 is equal to 30 minus 2x. This time we are left with a quadratic equation, and so we're going to attempt to solve by factoring first. So we must have it equal to 0, so 30 and negative 2x must move over to the other side of the equation. So subtract 30 from both sides and add 2x to make the right-hand side equal to 0. So x squared minus 4x minus 21 equals 0. If we attempt to solve by factoring, a times c would be negative 21 and b would be negative 4. So we need two numbers that multiply to negative 21, but also add to negative 4. We would get negative 7 times 3. And remember that those are your factors, they are not your solutions. In order to solve, you must set your factors equal to 0. So x minus 7 equals 0, and x plus 3 equals 0. So we end up with x is equal to 7, and x is equal to negative 3. But again, because this was a square root equation, we must check our answers to make sure that they actually create true mathematical statements. So I'll do that on the left at the top. So first we're going to plug in 7. So we have 7 minus 3 is equal to the square root of 30 minus 2 times 7. I'm going to erase my t-chart so I have more room to check. So we have 4 is equal to 30 minus 14. 7 times 2 is 14. And then let's see, 30 minus 14 is 16. And the square root of 16 is 4. So 4 does in fact equal 4. So 7 is a valid answer. Same process, but now we're going to use negative 3. So negative 3 is equal to, negative 3 minus 3 is equal to the square root of 30 minus 2 times negative 3. So negative 6 is equal to the square root of 30 plus 6. And then let's see, 30 plus 6 is 36, and the square root of 36 is 6. However, 6 does not equal negative 6, so that means that negative 3 produces a false statement, which means that that is an extraneous solution. Simplifying radicals. So first we must look at the index. So if the index is not shown, it's assumed to be a 2, which means it's going to be a square root, which means we are looking for pairs of numbers multiplied together. So I'm going to start breaking down 2100 by finding two numbers that multiply. I know that that's going to be 21 and 100. So 21 can be 7 times 3, and then 100, there's lots of ways to break down 100 if you would choose. I chose 50 times 2, and then 50 breaks into 25 times 2, and 25 breaks into 5 times 5. Now that all your number is broken down, let's break down the variables. So x cubed means there are 3 x's multiplied together. Y squared means there are 2 y's multiplied together, and we have 1 z. Now that everything's broken down, you are trying to group them up by groups of 2. So you want 2 of the same multiplied together. So you have 2 x's, 2 y's, so we have one group of each. I've got 2 2's and 2 5's. When you are simplifying, your groups are going to go outside of your radical and your singles are going to stay in. And both of these will be multiplied together. So if there are multiples, they're multiplied. So for example, 5 and 2, 5 times 2, I've got a group of x's and a group of y's. That will be multiplied to the radical with all the singles. We have 7 as a single times 3 as a single, x and z. Now that everything is in the correct location, we're going to simplify. 5 times 2 makes 10, x times y, square root, 7 times 3 is 21, xz. So our simplified radical is 10xy times the square root of 21xz. Simplifying this radical. So in this case, we have an index of 3. That is going to tell us that we have a cube root. The process from cube roots remain exactly the same as square roots, except now you are simplifying groups of 3 numbers multiplied together, not just 2. So same idea. We're going to break down 81. I like 9 times 9. 9 is 3 times 3, and the other 9 is also 3 times 3. M squared means there's 2 m's multiplied together. We've got 6 n's, 6, and then 13 p's. Okay, now that everything's broken down, we want to group them up by 3 of the same. So for the numbers, we have 3 threes. Now for m's, there's only 2, which means you cannot get a group of m's when you're talking about a cube root. If this was a square root, then you could group these up. But because it's cube, we have 2 singular m's without a group. N's, I can make 2 groups, and then let's see, p's, we can make 4 groups with a leftover. So same idea, groups on the outside, singles on the inside. So we have 1 group of 3's, we have 2 groups of n's, and we have 4 groups of p's all multiplied together. Then that is multiplied to the cube root of all of our singles. So 3, 2 m's, and a p. And now we simplify. 3, n times n makes n squared. 4 p's multiplied together is p to the 4th. And then the cube root of 3m squared p. There's our simplified radical.